Like most engineers, Dr. Annan Zhou strives for stability.
If we build a structure onto a ground, we design this structure based on the current situation. What we don't like is change.
Dr. Zhou's research deals with engineering problems caused by unsaturated soil. Soil above groundwater surface is partially saturated with water, while its other pores are filled with air. But when unsaturated soil comes in contact with water during so-called wetting events, such as rainfall or a pipe leak, the consequences can be dire.
Unsaturated soil can generate large deformation and even sudden strength loss during the wetting.
That could damage infrastructure like slopes, foundations and dams, and even trigger landslides. Dr. Zhou's research has shed new light on how we can more accurately predict and potentially prevent those failures. He's worked with other scientists to develop a new modelling framework that considers unsaturated soil's complex relationship with water, known as the hydromechanical interaction.
Hydromechanical interaction means hydraulic behavior is coupled with the mechanical behavior. So the typical hydraulic behavior of soil is water retention behavior, and typical mechanical behavior of soil is a straight-strain relationship.
Despite the hydraulic and mechanical behaviours affecting one another, the interaction isn't well explained in existing frameworks.
The current design method actually is based on the saturated soil mechanics. So that means we always assume the soil is fully saturated. So if it's fully saturated, it cannot reflect this kind of change. Like, for example, it's dry out and then saturated with water again.
And that's the sort of change that Dr. Zhou thinks will become more common as our warming climate brings intense periods of both drought and rainfall.
It is a quite complicated engineering problem. So once you start a research in this area, you will find you can't stop.
For his outstanding contributions to soil mechanics, Dr. Zhou has been awarded the John Booker Medal.